We are looking at equilibrium constant in terms of pressure. So I'm going to draw a balloon right there. So if your substance in a chemical reaction is a gas, which is more convenient, trying to measure the pressure of that gas or getting the molarity of that gas? It's easier to get the molarity if it were aqueous in water, but for a gas, it's better to get the pressure so you can just see how much it's colliding with the size of the container. You can use a pressure sensor, okay? So the K, it's no longer Kc because Kc stands for concentration. If you're using pressures, you have to call it Kp. And the formula is the same. In this example, you have the products, NH3, but instead of writing the bracket, which means the bracket like this, means molarity, okay, every time they write that. But we're not using molarity, we're going to use pressure. So you're going to do the pressure, the partial pressure of NH3 squared, right, over the partial pressure of N2. So here's the N2 to the power of 1 because there's a 1 there, times the pressure of H2 to the power of 3. So that's how you get that. The equilibrium expression, the generic would be if A plus B becomes C plus D, it's the same. You go C and D, but the pressure of C and D to the power, okay, just erase that, that looks ugly. The pressure of C to the power of whatever C is. This is C, this is D, this is A, and this is B. Okay, so the pressure of C to the power of C times the pressure of D to the power of D over the pressure of A to the power of A times the pressure of B to the pressure of B, to the power of B. Okay? Now, the actual number that you get here is numerically different than what Kc would be if you got molarity. Of course, they're different numbers. Okay? So these numbers are different. You have to calculate them. They're different. Okay? So the reason this works is because PV equals nRT and their pressure and molarity are proportional to each other. So if we look at PV equals nRT, molarity is moles over liters, right? So I'm going to put volume on this side. So here's pressure. As pressure goes up, the molarity, which is moles over liters, this is molarity right here, also goes up. That's why this works. Okay? Now you might wonder, how do you convert Kp and change it into Kc, or Kc to Kp? We have to, there's a formula for it. The formula is pretty simple. It is given right here. Okay? But all you have to do if you want to get Kp is get the Kc and multiply by RT and the change in N. Okay? So the change in N is nothing more than the moles of gas produced. So here you have 2 moles of gas produced minus the moles of reactant. So that is 3 plus 1 is 4, minus 4, 2 minus 4. So what goes there is -2. So you put -2 in there as a delta N. The R is this number right here. And you just plug in the temperature in Kelvin. You got that, you got that. You get Kc, and that's how you get Kp. Okay? I'm going to derive this for you in a different video. It'll be optional for you to watch that. But I'm just going to show you what the equation is, and this is how you solve for it. Okay, so Kp would be equal to Kc, which is okay, so I'm going to give you the formula first. So Kp is equal to, up here it says Kc times RT to the power of -2. Okay, so let's plug in some numbers in right here in this problem. So it says in the synthesis of ammonia from nitrogen and hydrogen, this is what happens. Kc is 9.60, so let's write that down. So Kp is equal to Kc RT minus 2. So Kc is equal to 9.60, and that has no units. R is given up here, 0.0821 latam per mole, 0.0821 liter ATM Kelvin moles, and temperature is 300 plus 273. You add 273 to that, you'll get 573. 573K. All right, the K's will cancel. Okay, and don't forget this whole thing, just a different color, is raised to the power of -2. -2 because this is 2, the moles of gas, 2 minus 3 plus 1, these are both gases as well, 4, so it's 2 minus 4 equals -2. Okay, it's probably the hardest thing to do is try to figure that out. Okay, pause the video and get the answer, please. So the answer is 0.00434. This is Kp. Okay. That also has no units because it's talking in terms of activities. If you have more questions on that, please read page 335. I'm sorry, 635 in your text. Okay, but just no units. All right, so we have, and that's it for this lesson.